Let's continue with 6th and last lecture on Class 10 Science, Chapter 10, Light. In this lecture, we shall discuss 3 important formulas related to refraction, that are lens formula, magnification and power of lens formula. So let's start with the formulas. But before learning about these formulas, we have to learn the sign convention used for solving the numericals for lenses. Now, most of these sign convention are same as mirrors. Let's revise them. So, the first rule says that the object should be placed to the left of lens. All distances are measured from optical center. And the optical center is like origin of lens. And distances to the right of optical center are positive. Distances to left of optical center are negative. And these rules are almost similar to the rules of mirrors. Also, all the distances above principal axis positive, all distances below principal axis negative. Now, one important and new rule for lenses is that always the focal length of convex lens is taken as positive and always the focal length of concave lens is taken as negative. This will be, all these sign convention will be used for solving numericals and you should always remember them. So let's start with the first formula, that is lens formula. Now again, for lens formula, 3 important variables are involved. The first is u, that is object distance or the distance of the object from the optical center of lens. Second is v, that is image distance from the optical center. And third is the f, that is focal length of the lens. Now the lens formula is that 1 upon v minus 1 upon u is equal to 1 upon f. So 1 upon image distance minus 1 upon object distance is equal to 1 upon focal length. Now let's solve a numerical based on this lens formula. So now let's solve a numerical based on lens formula. The question is from NCERT example. The question says concave lens has a focal length of 15 cm. At what distance should the object be placed from the lens so that it forms an image at 10 cm from the lens? So basically this focal length, that is the distance from this F1 to O, from the focus to the optical center, is 15. And we are having a image. This is an image, let's say it to be A dash B dash, which is at a distance of 10 cm. And from our previous from all the previous examples which we looked at in the 5th lecture, we saw that always in concave lens the image is formed on the same side as the object. So the object will also be on this side and the image will also be on this side. Also, image is virtual and image is erect, and it is on the same side as the object. These are the properties of image whenever image is formed by a concave lens. Now let's see whatever is given to us. We are given that the image distance is 10 cm and we are also given that focal length is 50. We have to find the object distance. What distance the object is placed. Now let's do the sign convention. Here you can see that we know that all the distances to the left are negative and to the right are positive. So here this v, as it is left on the left side, so it will be minus 10, and f is focal length is also on the right side, it will be minus. So both v and focal length are minus. Now applying the lens formula, we get that 1 upon v minus 1 upon u is equal to 1 upon f. Now we just have to put the values. So we will get that 1 upon minus 10 minus 1 upon u is equal to 1 upon minus 50. Now you know that if the minus sign is in the denominator, then we can also take it in the numerator. So we can take this minus sign of the denominator to the numerator. It will become minus 1 upon 10 minus 1 upon u is equal to minus 1 upon 50. If we take this u to this side and minus 1 upon 15 to this side, we will get that minus 1 upon 10 minus 1 upon 15 is equal to 1 upon u. Now we just have to solve this fraction. So this minus sign, two minus signs will get cut and plus sign will be there. So from here we can get that minus 1 upon 10 plus 1 upon 15 equal to 1 upon u. And again from here, if we just now have to take the LCM. So LCM is 30. So that's why minus 3 plus 2 upon 30 is equal to 1 upon u. We just have to solve and we will get that minus 1 upon 30 is equal to 1 upon u. So or if we take, transpose them, so we will get that u is equal to minus 30. So this is the final object distance, and as it is in minus, so we are again confirmed that it is to this side. So here will be the distance of 30. Now we have to tell that at what distance it is from the lens. So we can say that the object is to the 30 centimeter from the lens on the left hand side. Now let's discuss second formula, that is magnification. This says that magnification is equal to height of image upon height of object, and or magnification is equal to h dash upon h. Now there is also a second formula for magnification of lens, that is magnification is equal to image distance upon object distance, or magnification is equal to v upon u. Now if we combine both of these formulas, then we will get that image distance upon object distance is equal to height of image upon height of object. Now we did this because it will be used in many numericals ahead. So basically you will have to remember all these three formulas for magnification. Now again there are few conditions for magnification as we studied in the mirror. If magnification is greater than 1, then image is bigger in size than the object, or image is enlarged. If magnification is lesser than 1, image is smaller in size than the object, or image is diminished. Finally, if magnification is equal to 1, then image is of the same size as object. Now let's solve the second numerical. This numerical is based on both magnification as well as lens formula. The question says a 2 cm tall object is placed 15 cm away from a convex lens of focal length 10 cm. Find nature, position and height of the image formed. So basically there is a lens of focal length 10 cm, 10 and 10. The object is placed 15 cm away. Here is the object. Entire distance is 15. And the height of object, the size of object is given to be 2 cm. Now we have to find the position, nature and height. First let's find the position of the image formed using the lens formula. So here we are given height of object h to be 2 cm we are also given that the focal length is 10, and we are also given that the object is 15 centimeters away. Now basically you can see that this object distance is to the left, so it will be negative. So u will be negative in this case, u will be minus 15. But f will be positive. This is because I told you earlier that for convex lens always the focal length is taken as positive, so it will be plus 10. And height is also positive as it is above the principal axis. Distances above principal axis are always taken as positive, so height will be positive. First we have to find the position of image. We have to find v. We have to find the image distance. Now for finding image distance, we will apply lens formula. 1 upon v minus 1 upon u is equal to 1 upon f. We will replace values. We will get that 1 upon v is equal to 1 upon v minus 1 upon minus 15 is equal to 1 upon 10. Now this minus sign will get cut, plus sign will be there. So 1 upon v plus 1 upon 15 is equal to 1 upon 10. Now just you have to do the maths and you will get the answer. You will get the value of v. You just have to solve these fractions. So basically, after solving these fractions, we will get that the value of v is plus 30 centimeter. From this, we are able to infer two things. The first thing is that as v is positive, this means that image is formed on other side of the lens. So image will be formed somewhat like this on the other side of lens, and distance will be 30 centimeter from the optical center. But apart from this, we will also get that the image is inverted, as you can see here. And as image is inverted, all inverted images are real in size. All inverted images are real. But apart from this, we also have to find the height of image. So how we will get height? For that we will have to use the second formula, that is magnification formula. So let's apply magnification formula. Now here we are already given the height of object, that is 2 centimeter. So height of object is 2 centimeter, and we also know the value of u, that is value of u is minus 15, and we also know the value of v now, that is plus 30. What we have to find is the height of image. So basically we have to find the h dash. H dash is nothing but the height of image. Now using both of the magnification formulas, I told you an important relation. I told you that h dash upon h is equal to v upon u. If you are not able to remember it, then please go back to that formula and you will be able to recall it. Now we are given the values of h, u and v, and by putting that we will be able to find the value of h dash. So h dash is upon h, that is 2, is equal to minus is equal to 30 upon minus 50. So basically the value of h dash comes out to be so basically the value of h dash comes out to be minus 4. Now this means minus 4 centimeters. So basically this means that the image is formed below the principal axis. So the image is formed below the principal axis, and the height of image will be 4 centimeter. So from here we are able to get all the things that are the position, the nature and the height of image. With this we come to the end of this numerical. Now let's discuss the third and last formula related to lenses, that is power of lens, denoted by capital P. So the ability of a lens to converge or diverge the light rays depends upon its focal length. The degree of convergence or divergence of light rays achieved by a lens is known as power of lens. SI unit of power of lens is diopter and its symbol is D. And the relation between power of lens and focal length is that power is equal to reciprocal of the focal length. That is, P is equal to 1 upon F. Let's solve a numerical based upon power of lens. The question says that find the power of a concave lens of focal length 2 meter. So basically, first let's see what is given to us. We are given that the focal length is 2. Now, if you remember the rules, then they say that whenever we have the focal length of concave lens, then it is always taken as negative. That's why we will take the focal length as -2. Now, let's use the formula for power of lens, that is P is equal to 1 upon F. Now, if we put the value of F in this, then we will get that P is equal to 1 upon -2. Now, if we just solve this question by dividing them, by dividing 1 by -2, then we will get that power of lens is equal to -0.5 diopter. So with this, we come to the end of this entire chapter, that is light, reflection and refraction. If you like the lectures, then do subscribe to the channel, and if you have not yet visited the other lectures of this chapter, then the playlist of this entire chapter will be available in the description box along with the PDF of notes. So do check them out. If you have any doubt, then ask in the comment box and also give your feedback of the videos. Thank you.